All right, today we are opening up the chemist's cookbook to talk about a word that sounds, kind of scary, but is actually the secret sauce behind, well, pretty much everything. That word is stoichiometry. Let's dive in.
So, have you ever wondered about that? How do scientists get it right every single time? How do they know the exact amount of stuff to mix together to make a new medicine or a stronger material? It's not magic, I promise. It's a special kind of math that's actually a lot like something you probably do all the time.
Yep, that's it. At its heart, chemistry is a whole lot like cooking. Seriously, the secret to getting your head around all this is to just think of it as following a recipe.
Okay, so first up, chemistry is a recipe. Let's really look at how the rules of your kitchen apply directly to a high-tech lab.
Just think about it for a second. On the left, you've got a cake recipe. It needs exact amounts of ingredients, your reactants, to give you one cake, right? Your final product. Now, look at the chemical recipe on the right. It's the same deal. 2 parts hydrogen plus 1 part oxygen gives you 2 parts water. In both cases, those numbers are just ratios. They're the perfect proportions you need for everything to work.
But, to measure our ingredients, we first have to know what they are. So let's talk about the smallest ingredients that we're actually working with. What is everything made of?
Okay, so basically everything you can see and touch is matter, and its simplest form is called an element, like pure oxygen. Now, when you combine elements in a specific fixed ratio, like 2 hydrogens for every 1 oxygen, you get a compound. And in our little recipe here, the compound we're making is water, H2O.
But here's where we hit a snag, a big one. If our recipe calls for 2 molecules of hydrogen, how on earth do you measure that out? You can't just pick them up and count them one by one. They are impossibly, mind-bogglingly small. And this puzzle, it really stumped chemists for a long, long time.
So this brings us to the absolutely brilliant and surprisingly simple solution they came up with for counting the uncountable. It's a little concept called the mole.
And no, not the furry animal that digs up your garden. In chemistry, a mole is just a number. It's a very, very big number. It's defined as the amount of any substance that has exactly 6.022 times 10 to the 23rd power of particles in it. This ginormous number even has a cool name, Avogadro's number.
I mean, just look at that number. That's 602 sextillion. It's a quantity that's almost impossible to wrap your head around. But believe it or not, this single number is the universal counting unit that makes all of modern chemistry even possible. The easiest way to think about it is like this. When we say a dozen eggs, we mean 12, right? Well, when a chemist says a mole of atoms, they just mean Avogadro's number of them. It's just a convenient word for a specific quantity. It's the chemist's dozen. So, okay, how is this actually useful in the lab? Well, while chemists can't sit there and count out a mole of atoms, they can weigh it. See, every substance has a specific weight for 1 mole of its particles, and we call that its molar mass. So by weighing something in grams, they can calculate exactly how many moles and, from there, how many actual particles they have. It's this brilliant workaround. They count by weighing.
Okay, so now that we have our special measuring cup, the mole, let's go back to our chemical recipe and figure out how to read it the right way.
And this brings us back to our big word, stoichiometry. It sounds super complex, I know, but it's really just the official name for the recipe math of chemistry. It's all the calculations that let us follow that recipe perfectly every time.
And here it is. This is the single most important rule you need to know. When you see a balanced equation, like our one for water, those big numbers out front, they are not talking about grams. They are ratios of moles. So the recipe really means 2 moles of hydrogen react with 1 mole of oxygen to make 2 moles of water. Getting that unlocks, well, everything.
But what happens in the real world? I mean, you don't always have the exact right amounts of everything, right? So what happens when one of your ingredients runs out before the others? Let's go back to the kitchen again. Imagine you've got 10 slices of bread, but only 2 slices of cheese. It doesn't matter how much bread you have, right? You can only make 2 sandwiches before you run out of cheese. So the cheese is your limiting ingredient. Well, it is the exact same thing in chemistry. The ingredient that gets used up first is called the limiting reactant.
To put it simply, the limiting reactant is just the ingredient you run out of first. And because of that, it's the one that decides the absolute maximum amount of product you can possibly make. Because once it's gone, the reaction grinds to a halt.
And why does any of this matter? Well, because stoichiometry isn't just some abstract idea in a textbook. This exact chemical math is used every single day to figure out the right doses for life-saving medicines, to design batteries that last longer, and even to calculate the precise fuel mixture needed to launch a rocket into space. It is literally the foundation of our modern world. So, when you get right down to it, stoichiometry is really just the language of nature's cookbook. It lets us understand the recipes that build the entire world around us. And that kind of leaves us with one final thought. Now that you know how to read them, what will you create?